Namaste everyone. Welcome back to EduDose. I'm Dr. Satish Polshettiwar. Today's topic is a fascinating and modern concept in drug discovery, intrinsic network pharmacology. If you're a pharmacy or biosciences student, this is a must-watch. By the end of this video, you'll clearly understand how one drug can act on multiple targets and why this concept is shaping the future of pharmacology. So stay till the end. I'll also discuss a real case study on curcumin in Alzheimer's disease. Let's get started. Traditionally, we were taught one drug, one target, one disease. But real biology isn't that simple. Inside the body, thousands of molecules interact like a web. Enzymes, receptors, genes, and proteins are all connected. This interconnected system is what we call a biological network. Network pharmacology studies how drugs affect this entire web, not just one protein. And when we talk about intrinsic network pharmacology, we're focusing on how drugs influence the body's own built-in molecular networks. Its intrinsic signaling and regulatory systems. Why does this matter? Because most diseases, like cancer, diabetes, or Alzheimer's, are multifactorial. They involve many pathways going wrong at once. So, a drug that targets only one point often fails. But if we understand how drugs modulate multiple intrinsic pathways, we can design more effective and safer therapies. That's exactly what intrinsic network pharmacology helps us do. Connect the dots between drugs, targets, and biological networks. Here's how scientists study it. Data collection. They collect data about drug targets, disease genes, and protein-protein interactions from databases like DrugBank, DiscGenet, and String. Network building. Then they create a drug target disease network using computational tools like Cytoscape. Analysis. They identify key nodes. These are crucial proteins or genes that control the network. Validation. Finally, they confirm these connections through experiments or molecular docking studies. This approach helps predict synergistic effects, side effects, and even discover new drug uses, something called drug repurposing. Now let's look at a case study that perfectly explains the idea. Curcumin from turmeric in Alzheimer's disease. Alzheimer's involves oxidative stress, inflammation, and amyloid plaque formation. Curcumin is known to act on multiple targets, like AKT1, TNF, IL-6, MAPK1, and BDNF. When scientists built a network of curcumin Alzheimer's targets, they found it modulates several pathways, especially the PI3K ACT, MAPK, and NF-κB signaling networks. So instead of working on one receptor, curcumin influences an entire web of intrinsic pathways that protect neurons, reduce inflammation, and slow down degeneration. That's the power of intrinsic network pharmacology. It explains how one compound can produce multiple therapeutic effects. So where is this used? Drug repurposing, finding new uses for old drugs. Herbal research, explaining multi-target effects of Ayurvedic formulations. Adverse effect prediction, spotting network-level toxicities. Precision medicine, matching drugs to individual genetic networks. This approach helps us move from target-based to network-based drug discovery, a smarter, more holistic way to design medicines. To summarize, intrinsic network pharmacology teaches us that drugs don't act in isolation. They work within the body's complex network of interactions. Understanding these networks helps us design better, safer, and more effective therapies for modern diseases. If you found this helpful, like this video, share it with your classmates, and subscribe to EduDose for more simplified pharma and bioscience concepts. Let's keep learning, keep exploring, and make pharmacy smarter and together.
If you found this video helpful, please subscribe, like, and share it with others who'd benefit. See you in the next video.